Fine. So what we're doing today is we are going to discuss some of the past paper questions starting from 2013, and we'll be working backwards. And since most of you are in first term, I have already given you the equations without balancing them. The reactants and the products are provided to you. Okay, based on that, you have to complete the chemical calculation here. Let's get started. The first question. A 50 centimeter cube sample of a solution containing Fe2 plus is titrated with 0.02 m K2Cr2O7 in acidic medium. So when they say titrated, they are trying to find out the concentration of this one. Unknown concentration. They have given the volume of that. The concentration is not mentioned, so we are going to find it. The volume of K2Cr2O7 required to react with all Fe2 plus is 25 centimeter cube. Right. So the details with respect to dichromate, 0.02 m dichromate, 25 centimeter cube. And regarding Fe2 plus, this. 50 centimeter cube sample of Fe2 plus. If this titration is carried out using 0.02 m KMnO4 instead of 0.02 m K2Cr2O7, the volume of KMnO4 required is right. Fine. Now, how do we do this question? These are the two reactions, but when you do the final paper, the reactions will not be provided to you because by that time you would have learned these two reactions in Unit 6. But since you haven't learned these reactions right now, the reactions are provided to you, but we have studied these reactions under balancing equations. So you might have figured out the reactions, even if the reactions are not given. But anyways, first and foremost, we have to balance the reaction. How do we do that? Iron from +2 to +3, you can see +2 to +3, therefore the difference is 1. Chromium from +6 has gone to +3. Chromium from oxidation number +6 has gone to +3, difference is 3, but there are 2 chromium atoms, so there must be 6 here, and there must be 6 here. That's enough. You don't have to balance the rest. You just need the stoichiometry between iron and dichromate. And permanganate also, let's just quickly balance it out. Manganese from +7 goes to +2, therefore the difference is 5. Iron from +2 goes to +3, difference is 1, so that 1 comes here. Between permanganate and iron it's 5. So when will I be able to? You will be able to make equations like this in Unit 6. You have to wait until that. But these things they are in your list of reactions I have given, Amjad. But in Unit 6 we will learn it properly. What is permanganate and why does it happen this way and all those things. That's the issue, because when you change the medium, the products change. When you put OH minus, there will be different product. That's the issue. So until that, you'll have to be a little patient. If not, you should try to remember the commonly used equations. These things are there in the, we have used them. Anyways, now we know the stoichiometry between Fe2 plus and dichromate. And we know the stoichiometry between Fe2 plus and permanganate. They're not changing the number of moles of Fe2 plus, right? If the titration is carried out using 0.02 m KMnO4 instead of 0.02 K2Cr2O7. So they have not changed the number of moles of Fe2 plus. Since it's unknown, I'll take it as X. That means here also X. Okay. So let's start with the first reaction, which I've balanced in green color. In that reaction, we can say number of moles of Fe2 plus over number of moles of dichromate. Number of moles of dichromate, that is equal to 6/1. So number of moles of Fe2 plus is in fact equal to 6 times number of moles of dichromate. Correct? Right. So number of moles of Fe2 plus is going to be equal to how much? 6 times number of moles of dichromate. The information are given 0.02 m into 50 milliliter, 50 into 10 to the power minus 3. Let's leave it like that, no change. I'm not going to change it, right? So this is the first, from this reaction we can come up with this, and then the next reaction, the second one. Okay, from the second one, what is the ratio I have to write? I can write I'll go with, they're asking for the volume of permanganate to solve right now. Number of moles of permanganate over number of moles of Fe2 plus, that is equal to, what is the ratio? 1/5. So number of moles of permanganate, that is equal to 1/5 into number of moles of Fe2 plus. Number of moles of permanganate, that is concentration of permanganate, how much is that? 0.02, same concentration, no change, into volume of permanganate is what we are supposed to find out, volume of permanganate, and that is equal to 1/5. That's the fraction we have, into number of moles of Fe2 plus, we have it here, 6 into 0.02 into 50 into 10 to the power minus 3. Okay, right. Wait, did I make a mistake somewhere? 25 centimeter cube. No, we were sorry. 25 centimeter cube. What's going on? Here I have made a mistake here. Oh, sorry. It should be 25 centimeter cube here. 25. Because dichromate, number of moles of dichromate, I have to put the volume of dichromate. This 50 is for Fe2 plus. No? Sorry. Luckily, if I do it this way, the answer I'm getting is not there. You have to always double check the values once you substitute them. Concentration of dichromate is 0.02 and the volume of dichromate used was 25. Therefore, this part also has to be 25. 25. Right, now okay. Then let's simplify everything and finish it off. How do I simplify this? 0.2 and 0.02, you can get rid of that. 5 and 25, you can get rid of that and put a 5 here. So finally, volume of permanganate required, you can say volume of permanganate, that is equal to 6 into 5. 6 into 5 is 30 into 10 to the power minus 3 decimeter cube, that is 30 centimeter cube. Very good. So some of you had got fifth answer and that is the correct one. Fifth, okay. This is how you do it. A very simple question. All you need to do is balance the reaction correctly. And you can't say you can't do it because the reactions were provided to you. Okay, done. And next question comes from 2013 once again, 30th MCQ. Okay, now how are you going to do this? Again, the reactions are provided to you, so it should not be a problem. Right, here we go. Next one. A solid sample contains only calcium carbonate and magnesium carbonate. And I'll keep, you are supposed to try these questions at home. So I'll keep explaining them one after the other. When you have doubts, you can ask me in the chat so that I can stop and explain that specific part once again. A solid sample contains only calcium carbonate and magnesium carbonate. To completely react calcium carbonate and magnesium carbonate present in the sample, 42 centimeter cube of 0.08 mole per decimeter cube HCl were required. The anhydrous chloride salts from the reaction, these two, okay, chloride salts means these two salts. So when you say anhydrous chloride salts, who are they? Anhydrous means without water. So this calcium chloride and magnesium chloride. Calcium chloride and magnesium chloride without water, because during reactions water is produced. If you measure the mass, sometimes they will contain water. So what they do is they take it out, they dry it in the oven, and then they measure the mass. Reaction obtained by evaporation of the filtrate weight 0.19. 0.19 grams when the masses of the anhydrous chlorides were found. the mass of calcium carbonate present in the solid sample is. Okay, good. Now, what do we normally do? How do we normally start? We have a solid sample contains only calcium carbonate and magnesium carbonate, but they haven't given us the total mass of the sample. Sometimes they give it, right? So that approach doesn't work. Therefore, I'll take the number of moles of calcium carbonate as X because it's unknown, and my target is going to be finding X, and this is Y because they're asking for the mass of calcium carbonate. If I find X, I just have to multiply that by molar mass of calcium carbonate, which is 100, isn't it? 100, right? So the reactions are provided to us. These two are also not very difficult reactions, and whenever reactions are provided, most of the times the reactions will not be balanced in your first term paper. If you're not a first term student, you don't need the reaction. Then what you need to do here, you have to balance it. On the left to right side, there are 2 hydrogen atoms. I think I have to put a 2. When I do that, reaction is balanced. That's the only change I have to make. Here also the same thing. Just have to put a 2. Okay. Right. Now we know X moles of calcium carbonate. It's going to react with 2x moles of HCl to produce X moles of calcium chloride. Hope you can understand what's going on here. Okay, well, because 1:2:1. Similarly, Y moles of magnesium carbonate reacts with 2 Y moles of HCl and Y moles of magnesium chloride produced. Whenever they have given 2 compounds in a mixture, you take their number of moles as X or Y or A or B or P or Q, whatever the letter you like, and then you put them in the equation, and based on the stoichiometric coefficients, we decide the number of moles of other compounds. Right. So first information, I'll go with green color. This information, what is it? 42 centimeter cube of 0.0 m HCl were required. So we can find out total number of moles of HCl. Total number of moles of HCl. What is that going to be? That is going to be, that is going to be concentration into volume. Using concentration volume, we can find it. What is the total number of moles of HCl according to the question? According to here, you can say it is 2x plus 2y. 2x plus 2y. Okay, and that is equal to concentration of that is 0.088 into volume is 42 into 10 to the power minus 3. Don't forget, it's a centimeter cube. Fine. So I think we can take 2 out. It means x plus y here, and here 0.088 into 42 into 10 to the power minus 3. Therefore, you can simplify that 2 with these numbers. No, people 2, and with them this you can make it 21 or 0.04, whatever it is you like. And finally, you will arrive at an equation like this. That is x plus y. Now, one of you had a doubt. Shifa had asked me a doubt. Whenever you have a situation where you want to multiply, take as many decimal places as possible. Because if you look at the answers, they are very, very close. 0.05, 0.07, 0.09. Very small margins between the answers. So you have to look at the margin between these two. So if you make the slightest of errors, then you will not get the most accurate answer. Okay, right. So it's better to multiply the whole thing. 21 into 88. What is 21 into 88? 88, 21. So 88, 176, double of that. 8, 4, 1 balance, 8, 1. When you multiply 88 by 21, you get this, but there are 3 decimal places. So I'll put this way. 1.848 into 10 to the power minus 3. Let's consider all decimal places without ignoring anything. If you put it as 1.8 or 1.85, you will never get the correct answer. Okay, so this is the first equation. We have x and y, 2 unknowns. I need 2 equations, right? Okay, and then they have given the other information. That is that one I have mentioned in maroon color. What is it? The mass of anhydrous chloride salts, that is 0.19. So we can say mass of calcium chloride plus mass of magnesium chloride, that is equal to 0.190. Because I have 3 decimal places and I'll go with this. What is mass of calcium chloride? Because before I find the mass of calcium chloride, let's find out the molar masses of calcium chloride and magnesium chloride. That information is missing here. I think I might have covered it up, but you know from your previous questions, you know calcium is 40. Sorry, yeah, calcium is 40. Chlorine 2 into 35.5. Don't say it's not given, I couldn't do. These numbers are already used many times. Then 40 plus 71, it is 111 gram per mole. And molar mass of magnesium chloride, that is 24 plus 2 into 35.5. And that is 95 gram per mole. So what is molar mass? What's the mass of calcium then? Mass of calcium, you have to find it out. How? Number of moles of calcium chloride, mass of calcium chloride is number of moles of calcium chloride into molar mass of that. What is the number of moles? X, molar mass is 111. So 111x plus 111x plus mass of magnesium chloride is going to be y times its molar mass, 95y, equal to 0.190. So you have the second equation. When you add the masses of the chlorides, it should be 0.19. That's what they have said. So mass means number of moles in a molar mass. Yeah, careful. You always quickly double check the molar mass. If you make a mistake here, then it will be costly. Done. So I have 2 equations, people. I have to simplify the 2 equations and get the final answer. I need to get rid of y because y we don't want in the answer. Therefore, I can leave x and get rid of y. So the first equation must be multiplied by what? 95. Let's multiply the first equation by 95. That will give us 95x. 95x plus 95y equal to, this whole number must be multiplied by 95. Yes, you don't have calculators at the exam, so you have to do it. Let me quickly do it. 1.848 into 95, 585, 40, 0, 4 into 4, another 2 balance, 2, 4 balance, 9, 2, 7 balance, 3, 4 balance, 6, 7 balance, 16. Okay, people. So 0, 6, 5, 5, 7, 1. And there is a 10 to the power minus 3 as well. And there are 3 more decimal places. So it should be 175 point this. So finally, this is the value when you multiply 1.848 by 95. And don't forget that 10 to the power minus 3. Then you can put it this way. That is finally we'll arrive at 175.56 into 10 to the power minus 3. Therefore 95x plus 95y, that is going to be equal to 0.17556. Okay. This is the third equation. Okay, and I'll write the second equation here once again. 111x plus 95y equals 0.19000. This is the second equation once again. So to get rid of y, what should I do? Tell me, look. Get rid of y, I have to subtract the third equation from the second one. Second minus third, yes. What will I get here? 111 minus 95 is 16x. Yeah, 16x equal to, on this side, 0 minus 6 is 4, 9 minus 5 is 4, so 4, 2, 0. Okay, so X is equal to 0.02444 over 16. That is the number of moles of calcium carbonate. That is the number of moles of calcium carbonate. They're asking for the mass of calcium carbonate. So finally, what is the mass of calcium carbonate, people? Mass of calcium carbonate, that is number of moles into molar mass. Number of moles, this value 0.02444 over 16 into molar mass is 100. For calcium carbonate, molar mass is 100. So finally, we will arrive at a number like this, 2.44 over 16. Yeah, sorry. Yes, sorry. What am I doing here? Sorry, viewer. It should be 0.01444, not 2. Extremely sorry about that. Yeah, because you have to subtract from 19. Yes, exactly. 144. 1, 2, 4. Yes, sorry about that. Therefore, X is going to be equal to 0.01444 over 16. It's the number of moles of calcium carbonate. They're asking for the mass of calcium carbonate. So mass of calcium carbonate is equal to number of moles into molar mass. We all know the molar mass of calcium carbonate is 100, something we use quite often. And I think that is going to be 1.444 over 16. And when you divide 1.444 over 16, I think you will get 0.09. 0.0925, something like that, to divide that. Because in 144, there are 9 16s. No? In 144, there are 9 16s. So which one do we think is the best option here? Third one, right? The third one. This question is not very hard. It's just the decimal places look bigger. You just have to do the, what do you call it, multiplication carefully. That's it. So you can't say this question is difficult. No, this is chemistry. That's all. Only this is chemistry. The rest is maths. Right? And yep. You just have to be a little careful when you do. So see, arithmetic errors are the errors you are going to get here. When you subtract, when you multiply, when you make small slightest of mistakes, then if I had taken it as 0.024, then that answer, yeah, it will be wrong. I might have got something like this. So you have to be a little extra careful when you do that. Double check, always double check when you do a step. Okay, people. Right. Anyone got this answer? Third one? May I know? Right, good. I have few. There are few hands going up. Right, very good. And I hope others figured out where you could have done better. Okay, right. That is the second question for you. Now we'll move on to the third one. Right, third one, it's slightly different. Did we do this at the class? Third one. I kind of can remember. Did we do this at the class or not? Okay. We did. Okay, we did. Right. So since we did it, I'll skip it. You don't have to repeat it since we have done it at the class already. 13th one. I don't think we did the 13th one. And if you take 13th one, again, the reaction is provided to you. Thermal decomposition of 15.6 grams of hydrate metal carbonate produces 4 grams of metal oxide. The relative atomic mass of metal M. Okay, fine. Once again, the reaction is provided to you, but if you are not a first term student, then you should know the reaction. You should figure out the reaction. So because they have given metal oxide is formed. If the metal oxide is formed, That means definitely carbon dioxide, and this water must be separately removed from that. If I have 4 moles of metal oxide, right, 15.6 grams of this, but the problem is we don't know the molar mass of M, so we can't do much about it. I'll just put it 15.6 grams of this, and 4 grams of this is produced, metal oxide, in terms of mass. And if you take the number of moles, you know this is going to be X moles. If I take it as X, then X moles of metal oxide is going to be produced, X moles of carbon dioxide gas is produced, 4X moles of water is going to be produced, because in front of that 1, 1, 1, and there's a 4, and I think the reaction is balanced. MO, yeah, this is how it is. And remember, only the metal oxide here is a solid. Carbon dioxide and water, they are going to be released as gases. Okay, so if the initial mass was 15.6 grams and the final mass is 4 grams, the remaining mass, then you can say mass loss is equal to the mass of gases. That is how we normally do these type of questions. Mass loss, mass of gases evolved, mass of gases evolved. I'll put another word, total mass of gases evolved, that's going to be equal to the mass loss. If you had a solid at the beginning, and if you have another solid at the end of 15.6, only 4 grams remaining, the remaining mass is converted to gas, because there is a law called conservation of mass. Initial mass must be equal to final mass when you look at the compounds in a larger scale, but in nuclear scale it's not the same. That we will learn later, but in chemistry we can take it that way. Total mass of the reactants must be equal to the total mass of the products. So total mass of gases evolved, that will be mass of carbon dioxide plus mass of water vapor, and that is equal to what? Mass loss. What is the mass loss, people? Mass loss is 15.6 minus 4. 15.6 minus 4. What is mass of carbon dioxide? Mass of carbon dioxide is going to be okay, we all know molar mass of carbon dioxide. How much is that? Molar mass of carbon dioxide is 44. Molar mass of water 18. So mass of carbon dioxide is going to be number of moles X multiplied by molar mass 44. Mass of water, number of moles 4X into molar mass is 18, and on the other side 15.6 minus 4, that is 11.6. 44x plus 72x equal to 11.6. When you see those numbers, you should be really happy, because when you add 44 and 72, it is 116, which is equal to 11.6. 116x, that is equal to 11.6. So x this time is equal to 11.6 over 116. So x is equal to 0.1 moles. X is equal to 0.1 moles. X is an unknown. The question is about relative atomic mass of metal M. So the easiest thing to do is, they have given us the molar mass, they have given us the mass of MO. They have given the mass of this, but this is too big in this compound, so I'll go with MO. Now when you take for MO, for compound MO, you know the mass and number of moles as well. For compound MO, check number of moles of MO, that is equal to X, and that is equal to 0.1 moles. Mass of MO, that is how much? 4 grams. So you can use these two and find out its molar mass. What is the molar mass of MO then? What is the equation for molar mass of MO? Molar mass of MO is now mass over number of moles. So that is okay, molar mass of MO. Then next one, molar mass of MO is molar mass of M, which we are supposed to find out, plus what is the molar mass of oxygen? 16 equal to mass of that is 4, number of moles is 0.1, so that is 40. Okay, people, by dividing the mass dividing MO's mass by its number of moles, you will be getting the total molar mass of that, which is 40. And the molar mass of MO is molar mass of M, metal M, plus molar mass of oxygen, 16. So what is the value for molar mass of M we are getting? 40 minus 16, it is 24. So looks like it is magnesium. Therefore the answer is fifth one. May I know who got the fifth answer? Good. So I see few hands going up. Very good. Right. And yeah, if they have, if you couldn't get the answer, that's all right. This is something new you are learning. If they have given you thermal decomposition questions with masses, this is how you have to do. Consider mass loss as the total mass of gases evolved, and then develop the equations, get the numbers. Done. And then moving on, 14th one. At room temperature, a solution of 0.1 mole per decimeter cube HCl was slowly added to 100 centimeter cube lead nitrate solution until the reaction was complete. The resulting solution was filtered. And the residue was dried to a constant mass. The mass of the dry residue was 0.139 grams. The concentration of lead nitrate solution is okay. Nice. Good. So this is how lead nitrate and HCl are going to react with each other. You will be getting lead chloride as the precipitate. HNO3, of course, it's a solution. HNO3 is a solution. It can't be a precipitate. Therefore, in the question, they have provided us with the mass of lead chloride. What is the mass of lead chloride? That is 0.139. 0.139 grams. Okay. Sorry. And you have to balance the reaction as always. Don't forget that. I think if I add a 2 here and a 2 here, the reaction is fine. What is the question? We have to find out the lead nitrate concentration. What are the information provided? Yeah, that's easy. This is easy. Now, if you have X moles of lead nitrate, imagine if you have X moles of lead nitrate, what will be the number of moles of lead chloride? X, because 1:1 is the stoichiometric coefficient. 1:1 is the stoichiometric coefficient. Yeah. I think they must have provided us the volume of that, haven't they? Slowly added to 100 centimeter cube of lead nitrate. Yes. So they have provided us the volume of lead nitrate. And they are asking for the concentration of lead nitrate. Yeah, we are almost there. So all I need the number of moles of lead nitrate. If I know the number of moles of lead nitrate, for lead nitrate, I can use concentration into volume equation and find the concentration of it. For that, I need X. And to find out that, you can use this value. No? The precipitate is lead chloride and the mass of that is provided to you. First step in this question is finding the molar mass of lead chloride. Molar mass of lead chloride. You can see the numbers. 207 is for lead. Chlorine 2 into 35.5. So that is 207 plus 71, 278 gram per mole. Good news. 278 is double of 139. We know the mass of lead chloride, so we can find out the number of moles of lead chloride. That is equal to mass over molar mass. Mass is 0.139 grams over 278 gram per mole. There, what's going to happen now? Top, I can write it as 139 into 10 to the power minus 3. And the bottom you have 278. So when you divide 139 by 278, it's half. Yeah, half. 102 into 10 to the power minus 3. Instead of 102 into 10 to the power minus 3, I can put 0.5 into 10 to the power minus 3. That is the number. That is the number of moles of lead chloride. But we know something. What is it? But we know number of moles of lead nitrate should be equal to number of moles of lead chloride, because the stoichiometric ratio is 1:1, so that is 0.5 into 10 to the power minus 3 moles. And let's finish this off. We can say number of moles of lead nitrate, that is equal to concentration into volume. A number of moles is 0.5 into 10 to the power minus 3, and concentration is the concentration which we are supposed to find out. And the volume, what is the volume? 100 centimeter cube. So 100 into 10 to the power minus 3. That is the volume, right? That's it. We are almost there. 10 to the power minus 3 will be cancelled out. And lead nitrate concentration, what is it? Finally, lead nitrate concentration is 0.5 over 100. I'm getting 5 into 10 to the power minus 3. Anyone else who got it? Because this can be written as 5 over 1000, right, people? 5 over 1000. So it is 5 into 10 to the power minus 3 mole per decimeter cube. Third one. Careful. 5 into 10 to the power minus 4 is also there. So you have to accurately divide it and get the answer. Simple. Just extract the information from the question, the information they have already provided, and then based on the reaction, you have to consider the stoichiometry and get the answer. That's it. Very simple. Good. So that is 2012 for you. I think every year there are 2 such small questions. No? Fine. I think we did this question at the class. Did we? 2010 people? Did we do? 21. Yeah, we have done it. So I'm going to skip it. And I'm going to move on to 22nd question. Right, again, the reactions are provided to you if you haven't learned the reactions. When a mixture of 4 grams of sodium carbonate and sodium hydrogen carbonate were heated. This is sodium carbonate. This is sodium hydrogen carbonate. Now you can't say what is sodium carbonate, what is sodium hydrogen carbonate. We have done it under the naming of IUPAC compounds. So you should be able to figure them out. When a mixture of 4 grams of sodium carbonate and sodium hydrogen carbonate was heated, the loss in mass was 0.31 grams. So this is also similar to what we did earlier. No? The percentage mass of sodium carbonate. The percentage mass of sodium carbonate. So 4 gram sample of 4 grams sodium carbonate and sodium hydrogen carbonate sample. Mixture of 4 grams. Right. So they have given you the total mass of the mixture. If you have the mixture sodium carbonate and sodium bicarbonate are there, only those two are there. There are no impurities, and the total mass is given as 4 grams. Normally in such situations, how do we start? We take this as X moles, we take this as Y moles, something like that. So our target is finding X. They are heating this mixture, but unlike the previous cases, there's one of these compounds do not undergo thermal decomposition. That you will learn in unit 6. Sodium carbonate, you can't say sodium oxide and carbon dioxide. That's not how it works. Why doesn't it react that way? We will learn about that later in unit 6, and it has something to do with polarizing ability. People, can you remember polarizing ability of cations? It has something to do with that. Don't ask me why this reaction doesn't happen. We will learn that later, unit 6. So this is the only reaction which is going to take place, sodium bicarbonate. Right, but that reaction is not balanced, is it? So we have to balance the reaction carefully. What should I do to balance it off? I think I need to just add a 2 here. If I add a 2 here, it will be balanced. That's it. Because 2 sodium, 2 hydrogen, done. 2 carbon, 1, 2. 6 oxygen atoms on the left side. 3 plus 2 plus 1, 6. Done. So the reaction is balanced. And we have Y moles of sodium carbonate to start with. Y moles. How many moles of... Okay, sodium carbonate, people, it's a solid. it will be remaining, and carbon dioxide and water will be evaporating. So the mass loss, like I said in the earlier question, it will be the mass of the gases. How many moles of carbon dioxide will be produced? Y moles of sodium bicarbonate, 2 here. 2 is to 1. 2 is to 1. 2 is to 1. Therefore, half of that amount, half of that moles of carbon dioxide will be produced, because it's 2 is to 1 ratio. So if Y moles of sodium bicarbonate was used, 0.5 Y moles of carbon dioxide will evolve. I'll write it here. 0.5 moles of carbon dioxide will evolve. And how many moles of H2O is going to evolve? Again, 0.5 Y moles of H2O is going to evolve. Half of this amount, half of the number of moles. And we don't have to worry about sodium bicarbonate because it doesn't undergo reaction. Therefore, just like the previous question, I can say total mass of gases evolved. Total mass of gases evolved, that is equal to mass loss. What is the total mass of gases evolved, people? That is number of moles, not number of moles, mass of carbon dioxide and mass of water. That is equal to mass loss is given 0.31. Mass of carbon dioxide, that is number of moles multiplied by its molar mass. Mass of water, that is number of moles multiplied by its molar mass. This is 22Y, this is 9Y, equal to 0.31. So that is 31Y equals 0.31. Again, we know we are going in the right direction because the numbers are quite convenient ones. I'm getting 0.01 moles. So what I have found here is number of moles of sodium bicarbonate, which is 0.01 moles. The question is the percentage of mass of sodium carbonate. So using this number, I can find out the mass of sodium bicarbonate. Now, people, for that I will need the molar mass of sodium bicarbonate. What is the molar mass of sodium bicarbonate? Molar mass of sodium bicarbonate is going to be 23 plus 1 plus 12 plus 3 into 16. I think that is 84, isn't it? 84 gram per mole. So using that, I can find the mass of sodium bicarbonate. Mass of sodium bicarbonate is going to be equal to number of moles into molar mass. 0.01 into 84, and that is 0.84 grams. 0.84 grams. No, it can't be liquid because you are heating. No, when you heat it will evaporate as a gas, water vapor. During thermal decomposition, water must be taken as a gas. It can't be taken as a what do you call that, liquid. We'll be usually heating it for high temperature. And right, if that's the if that's the mass of sodium bicarbonate, then what is the mass of sodium carbonate? Now we know sodium mass of sodium carbonate and mass of sodium bicarbonate, that is equal to 4. Mass of sodium carbonate is what we need, and that is equal to, that's plus mass of sodium bicarbonate is 0.84, and that is equal to 4. So mass of sodium carbonate, that is equal to 4 minus 0.84. So 4 minus 0.84 is 3.16, isn't it? 3.16. Yes, that's it. So now we have to find out the mass percentage of sodium carbonate. That's the question, and you know what to do. That is mass of sodium carbonate divided by total mass into 100. Mass of sodium carbonate is 3.16. Total mass is 4 into 100. 316 over 4. I think it should be 79. Anyone who got 79? Is there an answer like 79? Yep, fourth one. 79. Good. I see 3 hands going up. Shifa, Azran, Khadija. Good. Just like the previous question, just a few, 2 questions before this, we did a similar question. But this is slightly different. They had given just one compound. Here, there's a mixture of compounds, but it's not that difficult, yeah. Very simple, and the numbers are also the division and all are very easy. So you can invest some more 2 or 3 minutes to this and get the answer. You don't have to skip these kind of questions. All the questions we did so far, you can do. There weren't many complicated ones, no, so far. Right, good. 79 is the answer. Right. Then next one, 2010, second question. Okay. I don't think we attempted that at the class. 0.331 grams sample of lead nitrate contaminated with sodium nitrate, so that doesn't have only lead nitrate, was dissolved in 100 centimeter cube of water. Excess H2S gas was then bubbled through this solution until the precipitation was complete. The mass of dried precipitate was 0.200 grams. The percentage of I think something is missing there, no, people? Some information is missing there. The percentage of who? Lead nitrate or sodium nitrate? Okay, now that's going to be interesting. Give me a second, let me check 2010 paper. Okay, someone has checked it, I think. Purity of the sample. Yeah, purity of the sample. That is a small printing error. The percentage purity of the sample. Percentage purity. If they are talking about purity, whose percentage we should find out? Tell you. Sample of lead nitrate. Sample of lead nitrate contaminated with sodium nitrate. Therefore, the question is about who? Lead nitrate. What we have to find out is okay, when you say percentage purity, give me a second. When you say percentage purity, that means we have to find out mass percentage of who? Lead nitrate. Because that is the main compound in the sample. Sodium nitrate is just a impurity. So this is going to be your target. For that, I need to find out the mass of lead nitrate. It is going to be very easy. It's going to be very easy. First of all, let me check whether the reaction is balanced. Yeah, I just need to put a 2 here. The reaction will be balanced. And who do you think is a precipitate here? Lead sulfide is a precipitate, people. Lead sulfide is the precipitate form when you pass H2S gas through in lead nitrate solution. Lead sulfide is the precipitate. The mass of dried precipitate. Okay, so if I have X moles of lead nitrate, say I'll take the number of moles of these as X moles. If I take X moles as its number of moles, X moles of lead nitrate will react with H2S and X moles of lead sulfide is going to be produced. Number of moles of lead sulfide and number of moles of lead nitrate, they are going to be equal based on this reaction. Right, so let's get to work. First of all, we have to find out the number of moles of lead sulfide. For that, I need molar mass of lead sulfide. What is the molar mass of lead sulfide, people? 207 plus 32, 239. 239 gram per mole. Yeah. Then number of moles of lead sulfide. What should I do? Mass is given, divided by molar mass. Mass 0.2, molar mass 239. Right, I'm not going to divide it. I think I might be able to simplify it later. But what I'm going to do is I'm going to multiply up and down by 5. Okay, so it will be 1 on top, and at the bottom it will be 139. Yeah, if not, we'll leave it like this. We'll leave it like this for the time being. Moles. We'll not make it complicated and unnecessary. Moles. Right, that's the number of moles of lead sulfide. So, but we know number of moles of lead nitrate and lead sulfide are equal. So that is equal to 0.2 over 239. Now I can find out the mass of lead nitrate. How? By finding its molar mass. What is the molar mass of lead nitrate, people? Molar mass of lead nitrate. Anyone found? It must have some relationship between 239 number we get here. 207 plus nitrogen 14 plus 48 for 3 oxygens no? Into 2. 62 into 2, 124. Yeah, 124 or 331. Oh, okay, 331. Here also we have 331 gram per mole. Exactly 331, is it? Yes, perfect. I have the number of moles of lead nitrate. I know the molar mass of lead nitrate. Using those two, I can find out the mass of lead nitrate. So, mass of lead nitrate, that is equal to number of moles into molar mass. Number of moles 0.2 over 239, molar mass 331. Still, I'm not dividing it. Now we have to find out mass percentage of lead nitrate, that is the percentage purity. How do I do that? That is again mass of lead nitrate over total mass into 100. What is the mass of lead nitrate? 0.2 over 239 into 331 over total mass is 0.331, I believe. Yeah, into 100. So the positive news is this 331 and this can be cancelled out. We will be getting 0.001. Okay, and finally we will be arriving at an equation like this, that is 0.2 into 100 is 20 over 0.001 into 239 is 0.239. What is the answer you're getting here, everyone, when you divide them? I have to divide 20 by 0.239. Anyone did that? So I will have to divide 20,000 by 239. No? So if you take only the first number, it's enough. You have 68, 79, 84. How many 239s are there in 2000? That's the question. 8. Okay. So I see few of you have got the answers, and it says 83.6. Yeah, 83.6. Few of you have got 83.6. That means the best answer is 84, roughly 84. That you can do the math. Once you get 8, you can just choose the fifth one. You don't have to accurately find 84 because there's only one answer in the 80s. No, understood? That's why they have not troubled you much, because you have to do some work here. So they have given you the difference between the answers are big, huge. So once you get 8, that means you know, okay, it should be something in the 80s, the answer, right? Once again, not very difficult, people. You find the number of moles of someone and you take the number of moles of that as the other one based on the stoichiometric ratio, and then they have given mass or molar mass, whatever it is, just finding it. Simple. So whatever the reactions equations we learned, we have used it, but the way you use it, you have to do it carefully. That's it. Now, right. Next, so this doesn't have anything to do with calculations, but let's just have a look at it quickly. In the question number 24, the oxidation number of sulfur and nitrogen atoms in the following ions are respectively. Okay, right. Never mind. So, revision for us. I will draw the product. I'll draw the compound bigger. Nitrogen and sulfur. No, nitrogen. Hydrogen, and here sulfur, double bond O, here also double bond O, here O minus, and here H. Right. Now if you take electronegativities, Among these compounds, we definitely know who has the highest electronegativity: oxygen. After that, nitrogen. After that, sulfur. After that, hydrogen. So when nitrogen is creating bonds with hydrogen, nitrogen is going to get -1 because that's one bond, one bond. So -1. Here also -1. From this bond it will get -1. -1, -1, -1. And due to this bond, sulfur is going to get +1. And due to this bond, sulfur is going to get +2. Okay, +2. Due to this bond, sulfur is going to get +2. Due to this bond, sulfur is going to get +1. I hope you can understand what's going on here. When there are two bonds between two elements, the number of bonds 2, and we give the plus value of that to the less electronegative element, and we give negative for the more electronegative element. If you take nitrogen, you see nitrogen doesn't have any other charges, just these oxidation numbers we got from hydrogen and sulfur. So -1, -1, -1, -3. Sulfur +1, +1, +2, +2, +6. Answer is second. Very, very simple. All you need to do is this. See how long it takes, not just a few seconds. You don't have to draw it again. You will have the diagram on your paper, and the paper itself you can quickly mark and get it. Even you don't even have to mark it, you can do it in your head. Second answer. Okay, these things should be you should be very thorough with this, because 50 MCQs means for every MCQ you can't spend equal amount of time. This MCQ, it should take less than 20 seconds for you if you have enough practice, or 30 seconds maybe, I don't know. Next one. Right, another chemical calculation. The reaction is provided to you, but again this reaction is also not a difficult one. I think it's there in O level also, the decomposition of H2o2. Right. 1 decimeter cube of an aqueous solution of H2o2 was heated to complete dissociation. The volume of oxygen evolved was 8 decimeter cube at standard temperature and pressure. STP means standard temperature and pressure. The concentration of H2o2 solution. Okay. Again, should be a very simple question, but before we start, we have to balance it. I think I need to put 2 here and a 2 here. Easy. Balanced. Okay. And if you have X moles of H2O2 used at the beginning, how many moles of O2 will evolve? Half of that. So 0.5 X moles of O2 will evolve. Okay, 2:1. X it should be half of that. I think I need X to get the final answer, because I know the concentration of H2O2 solution. They have given us the concentration of H2, volume of H2O2. 1 decimeter cube of an aqueous solution of H2O2, and we need to find out the concentration of H2O2, and they have provided us the volume of oxygen, that is Tp. So if you find for using the volume of oxygen, you can find number of moles of oxygen. Using the number of moles of oxygen, you can find X. X is number of moles of H2O2. We know the volume of H2O2. You can find the concentration. Let's start. They have given you the volume of a gas. So whenever volume of a gas is given, this, you can use this equation. Number of moles is equal to volume of the gas divided by the molar volume. Volume divided by molar volume will be number of moles. So number of moles of oxygen, in fact, it's equal to volume of oxygen is how much we were. Number of moles of oxygen we know already, 0.5x. Volume of oxygen is 8. And molar volume is 22.4. 1 over in 224, I think there are 28 eighths, so it should be 2.8. Agreed? How do I know that? Because in 200 there are 25 eighths. In 24 there are 3 eighths. 25 plus 3, 28. So if you divide, if you simplify 8 and 2, 22.4, you will get 1 over 2.8. So X is going to be equal to 1 over 2.8 into 0.5, because 0.5 will go down. Therefore, I'm getting X equals to 1 over 1.4 moles. That's the number of moles of H2O2. Simple. Then if you go with number of moles of H2O2, that is equal to concentration into volume. What is the number of moles of H2O2? That is this 1 over 1.4 equals to concentration. What is the concentration, people? That's what we have to find out. Volume is exactly 1 because 1 decimeter cube. Concentration of H2O2, that is equal to 1 over 1.4, 10 over 14, 5 over 7. What is it, people? I think it should be 0.71. No? Anyone who got 0.71? Very simple. Yeah, that's a simple one. Good. So the answer is 4. Clear? Right. That's done. And now let's move on to the next part. Okay, we have a few more questions, but all of them are not based on reactions. Then let's have a look at this question. Which of the following conversions is neither an oxidation nor a reduction? Okay, 2009. Now this is also something you can do based on chemical calculations. Right, neither oxidation nor reduction. That means there shouldn't be any change in oxidation number. That's all. Now we were finished. Now if you take A, in A, I will mark it here itself without wasting our time. In A, what is the oxidation number of nitrogen? In this one, when you say N2O3, it is the average oxidation number of nitrogen there is going to be +3. And average oxidation number of nitrogen here is going to be +1. So there is a change in oxidation number. It is actually getting reduced, no? Average. But in this one, look at chromium. What is the oxidation number of chromium here, people? Chromium oxidation number is +6. And here also it is +6. No change. So this is neither oxidation nor reduction. And if you go to statement C, hypochlorite, or if not chlorate 1, in hypochlorite or chlorine is +1, and in chloride, chlorine is -1. So the first reaction is actually reduction. Okay, this one is reduction. This is also reduction, because from +1 it has reduced to yeah. And the last one, what is the oxidation number of sulfur in this? SO3 oxidation number of sulfur is +6, and in SO4 2- is also it is +6. Read the question once again. Which of the following conversions is neither an oxidation nor reduction? That is, so the answers must be B and D correct. A and C are reduction reactions. So these two are wrong. Therefore, if B and D are correct, what is the option, people? If B and D are correct, we know in ABCD type questions, it should be the 5th option. Because first answer is for A and B correct, second is for B and C correct, third is for C and D correct, fourth is for A and D correct. Any other options, it should be the 5th one. So we have only B and D correct here, but now, yeah. So it should be the 5th. Understood? I quickly wrote the oxidation numbers. I hope you quickly can find it. You should be that fast. We have I think in our discussions we have written all these species and found the oxidation numbers. So you should be able to do it. Next. Right. Now for a change, there's a statement question. Let's have a look at that. As oxidation and reduction reaction always occurs simultaneously. And oxidation and reduction reactions I think it should be an oxidation reaction and a reduction reaction. Do you agree with that? Must be a change there. Do you agree with that statement? I mean, is it correct or wrong? Always occurs simultaneously. Is it correct or wrong? It should be correct, no? Because if someone loses electrons, someone should gain electrons, no? So when you say that's correct, the first statement has to be correct, because when you say oxidation, what is the meaning of that one? Losing electrons. And when you say reduction, it means gaining electrons. So someone loses the electrons, that means someone should gain the electrons. The electrons can't just hover around in the reaction mixture. Someone should gain it, someone should lose it. So oxidation and reduction should happen simultaneously. All chemical reactions are disproportionation reactions. That's completely wrong. Okay, not all, only few. Okay, no, few examples for disproportionation reactions. I don't know whether you can remember. We wrote some and we balanced them like in a special manner, because we have to start balancing them from the right side. So just I'll put some examples for you. See if you can remember. This is one such a very famous example. Chlorine. When chlorine reacts with concentrated sodium hydroxide, and when chlorine reacts with diluted sodium hydroxide, it will still undergo disproportionation, but with different products. Sodium chloride, sodium hypochlorite, and water. So here if you see chlorine is 0 here, oxidation number. Here chlorine is -1, and here chlorine is +5. Same element undergoing both oxidation and reduction. That is what you call disproportionation reaction. Can you remember any other disproportionation reactions we learned? Wait a minute. There are more. Sulfur can react with sodium hydroxide, diluted, and it will form sodium sulfide and sodium thiosulfate. Don't worry about these things. We will learn about this in unit 6. 0 here, -2 sulfur here, +2. Likewise, there are so many such reactions, people. Okay. When you say disproportionation, the same element must undergo both oxidation and reduction. That is what you call disproportionation. Yeah, there are a lot. Good. Now Rishma said NO2 plus water. Right. Yeah. Just to add NO2 plus water, and Anisha says phosphorus plus sodium hydroxide. Yes. Since they pointed it out, I'll quickly write it out. Now NO2, when it reacts with water, it will produce a mixture of these two acids, HNO2 and HNO3. There nitrogen is +4 here, and here nitrogen has got reduced +3, and here it has got reduced. It has got oxidized actually +5. And Anisha suggested phosphorus reacting with sodium hydroxide. If it is diluted, you will be getting PH3 and NaH2PO2 plus water. Yeah. Don't worry, you don't know these things yet. Phosphorus is 0 oxidation number. Here phosphorus is -3 in phosphine, and here is +1. Same element has undergone both oxidation and reduction, and it doesn't happen in every reaction. These are few of the rare examples. Okay, again another question about oxidation states. Oxidation states. So let's finish it off quickly. The oxidation states of sulfur 1 and sulfur 2 atoms in the following molecules are. Right, again small formalities, but I just draw it bigger and try to finish it quickly. We know fluorine is the most electronegative element of all, so whoever is attached to fluorine should have a positive oxidation state. Therefore, you can see from each of these single bonds, sulfur is going to get +1, +1, +1, but from here sulfur is going to get 0 from this sulfur, because sulfur and sulfur same elements, no? And this sulfur is also going to get 0 from this sulfur bond. Here it will get -1. Therefore, if I take this sulfur in particular, it has an oxidation number of +1, +1, +1, 0, +3, and this one is -1, is it? So +3. Oh, sorry. Yes. +1, +1. Right. Good. not minus. God, sulfur, how can sulfur be minus? Okay. Should be +1. Come on, +1. Yep, +1. Sorry. Yes, because with fluorine, anything connected to fluorine should be plus. And I think we can settle to third answer. Remember, third one. Yes, good. So similar questions are repeated. Moving on. Next one. Right, we have just 3 more questions. So after these 3 questions, we can end the first session. And I think I gave you homework from model papers. So in our second session, we can discuss those model paper questions, structure and essay. That will be done. Right. So 2008. Which of the following requires the highest number of moles to oxidize 1 moles of I minus? Sorry, then I think I should have given you the reactions for each and everything. Right, I think, could you find out these reactions, people? No, I don't think. No, I don't think you would have. Some of them you might know. This one we might have written, but the others I don't think we did. Okay, I'll just write the reactions one by one and let's see how it works. The first one, when chlorine reacts with I minus. Okay, when chlorine reacts with I minus, people, you'll get a product like this. Now you can do it now. You can do it and tell me the answer. Huh? It will produce I2 and Cl minus. That's the reaction of chlorine with I minus. After finishing unit 6, you will be able to write this on your own. And chromate, now when you say K2CrO4, don't worry about that K2 because it's potassium plus, it doesn't react. Just take the anion. Chromate reacting with I minus. Chromate should react in basic medium, actually. Basic medium, and it will produce once again I2 and Cr3 plus. And water will be produced, but we don't have to balance everything. All you need to do is you need to find the numbers in front of chromate and I minus. That's enough. You don't have to balance the entire reaction. Next one, dichromate. Of course, dichromate with I minus will react. We know this reaction in acidic medium. Chromate is not stable in acidic medium, so chromate should react in basic medium. Dichromate should react in acidic medium. You will get I2 plus Cr3 plus. Don't worry about the reactions. Once again, I'm repeating. We will learn this later. And when you say FeCl3, forget about Cl minus. It's ion, Fe3 plus. Fe3 plus will react with I minus, and it will produce I2 and Fe2 plus. And fifth one, permanganate. Yeah, that should not be a problem for you, but still I'll give you the reaction. I minus and the product I2 and manganese 2 plus. Reaction should happen in acidic medium and the other product will be water. Okay, people, now tell me, in which of the following the highest number of moles of which of the following requires the highest number of moles to oxidize 1 mole of I minus ions? Okay, so in everything I have 1 mole of I minus. Right, now you're going to tell me. I have given you the reaction since most of you, almost all of you, are still in first term. You will not know the reactions. Then the reactions are given to you. You have to tell me in which one we will have which one of these compounds will need the highest number of moles to oxidize 1 mole of I minus. Right, I'll give you a minute. But the problem is you need to balance the reactions, people. Right, then we'll do it now. To balance the reactions, first one, you want to balance it, what should I do? All you need to do is just put a 2 here and a 2 here. Reaction is balanced. And in this one, as you can see, chromium from +6 has gone to +3. Here chromium again from +6 has gone to +3. Iron from +3 has gone to +2. no need to write it, but never mind. +3 to +2. And permanganate from +7 to +2. Right, then how do we write the stoichiometric coefficients? And oh sorry, in everything iodine is 0. No, from -1 iodine goes to 0. -1 to 0 means 1. For iodine, the oxidation state change is 1, I minus to 0. So that 1 will come in front of all of these. And in front of I minus number is only the most important one. Now tell me what is the number I should put in front of this I minus? From +6 to +3, difference is 3. From +6 to +3, difference is 3, but there are 2 chromium atoms, therefore I have to put 6. Okay, +3 to +2, difference is 1, that one comes here. If you want to balance it properly, you will put a 2 and 2 here. You put a 2 and 2 and 2 here, balanced the whole reaction. Here, +7 to +2, difference is 5. That's enough. You don't have to balance H plus and all. That's a complete waste of time because our problem is between these two. Okay, now people? Tell me how many number of moles of chloride will be needed? How many number of moles of chloride will be needed? How many number of moles of chloride will be needed? We'll write them one by one now. Number of moles of chloride needed will be half of this, 1:2, so it's half moles, 0.5 moles. You can you're getting numbers, half moles. Half, I'll put 102 then, 102, yeah, 102 moles. And here 1:3, so if 1 mole for 3, here it will be 1/3 moles. 1/3 moles, no? Right, and here it is 1/6 moles. And here 1 moles, because it's 2:2, 1:1. And here it will be 1/5 moles. Therefore, the obvious answer is third one, because all the others are fractions which are less than 1. No, not third one, fourth one, sorry, fourth one. This is half, right? There are, in case in a future question, if they ask you to write arrange them according to the number of moles, so number of moles required in the ascending or descending order, how will you write? Who will have I'll go with number 1, 2, 3, 4, 5. Who will have the highest? 4, because it's 1. After 4, who will be the next people? 1, because it's half. 1/2. When the denominator is smaller, the fraction is higher. After that, it will be second one. After that, it will be fifth one, because 1/5. And after that, it will be third one. In case in future, if they ask you to arrange them in this order, the number of moles required. So that's how it's going to be. Right. Okay then. Right. Then 7. Okay, it's almost 7 now. Right, fine. We have 2 more questions. We'll finish this off. Next question is from again 2008. Every year looks like there are 2 questions from chemical calculations, MCQs, no? And there will be an essay question also. Essay questions, I didn't dive into them now itself. We'll do it after we study unit 6, people, because you need reactions and all. That's the issue. If I do it now, it will be a little too overwhelming for you, the final paper questions. So let's skip it. Next question is from 2008. When titanium dioxide is heated in the presence of H2 gas, another oxide of titanium, this is titanium, not titration, titanium is formed. If 1.6 grams of titanium dioxide is produced, 1.6 grams of titanium dioxide produces 1.44 gram of this oxide, the formula of the oxide. Now this is going to be a tricky question. Yeah, it's going to be very tricky. Right, okay. Now first of all, they have given us the, look at the information provided us, 1.6 grams of titanium dioxide. They have given the mass of titanium dioxide. So using that, we can find out the number of moles of titanium dioxide. How is that? First of all, molar mass of titanium dioxide, that is 48 plus 2 into 16. That is 80 grams per mole. 80 grams per mole. And then we'll find out the number of moles of titanium dioxide, people. Number of moles of titanium dioxide is mass over molar mass. Mass is 1.600 over 80. And I think that is going to be 0.02 moles. Is it? 0.02 moles. That is the number of moles of titanium dioxide. Yeah. And it's going to react with hydrogen and it's going to produce another oxide. I don't think we will be able to directly find the answer. We'll have to choose each and see which one is suitable. Trial and error. So I'll do one by one. If TiO is produced, so first one, let's just check one by one. Then the reaction has to be TiO2 and TiO. TiO2 means TiO2 reacting with hydrogen, and TiO will be produced, and another compound will be produced if getting oxidized. This is getting oxidized or reduced, so this should get oxidized or something like that. Some other product will be obtained. H2O, maybe, probably H2O. Yeah, H2O is going to be produced. Even without hydrogen, you can do it now. This TiO2 should produce TiO. The problem is between these two. Now we know this is a reaction, people. This should be the reaction. Reaction is balanced also. So we know 0.02 moles of this is there, titanium oxide. Here, if 0.02 moles of titanium oxide reacted with H2, how many moles of titanium oxide? No, titanium dioxide is 0.02. How many moles of titanium oxide should be produced? Same, 0.02 moles. Okay, 0.02 moles, because it's 1:1. So what should have been the mass? So mass of titanium oxide should be number of moles into molar mass. Number of moles is 0.02 into what is the molar mass of titanium oxide, people? 48 plus 16. And what is the answer there? We're getting 0.02 into 48 into 16 is plus 16 is 64. Is it 64? And it should have been 1.28 grams. 1.28 grams. But they are getting 1.440 grams of that oxide. So this is wrong. No, this is wrong. Why? Because not 1.44. Understood? I think we'll have to do it like that. Trial and error. And now the second one. Second reaction. Second one, even without hydrogen, you can do it, people. You don't worry about hydrogen. Second one, imagine titanium Ti2O3, titanium 3 oxide. It is going to react with someone and it's going to turn, titanium dioxide is going to react with hydrogen and it is going to turn to Ti2O3. But now you have to be a little careful. What should I do, people? I should put a 2 here to balance the reaction. No? 2 is important because titanium is not balanced on the left side, so I have to put a 2 here. You have to be a little careful now. Okay, and and water will produce. We don't care about that water because we have to focus on this and this. Now in the question, they have mentioned 1.6 grams of titanium dioxide or titanium 4 oxide, 0.02 moles. 0.02 moles of TiO2 should produce how many moles of Ti2O3, tell you? 0.02 moles of that should produce how many moles of Ti2O3? 0.01, exactly. 0.01, half of it. Why? Because the ratio is 2:1. So it should produce half of it. Half means 0.01 moles. If 0.01 moles had been produced, what should be the mass? So mass of Ti2O3, again, number of moles into molar mass, number of moles 0.01 into molar mass. Molar mass, people, 2 into 48, that is 96. I think this is the answer. Agreed? 2 into 48 plus 3 into 16. And when you multiply everything and add everything, you will be getting 144 here. So 0 0.11, 0 0.01 into 144, final answer. That is the answer we were looking for, 1.44 grams. They are saying 1.44 grams of some oxide is produced. So first one didn't work, second one works. So I think we'll go with second answer. Normally when you have to do trial and error method, you should get the first or second answers most of the times. That's how it is, because they will not expect you to check everything, because it will consume a lot of time now, people. We can't definitely say which oxide is going to be produced. Sometimes you will have to do it in the trial and error method. You have to take the answer, assume the answer is correct, and check whether it tallies with the information provided. So I assume, first of all, I assume TiO is correct, and I found its mass. It was 1.28, did not match with the answer number they had given. Understood? But the second one, I assume that was correct, and then got a mass, and that mass was same as the mass provided in the question. That is how you do it. So it's good that we did the question. Sometimes in future they might change this to another metal and a different oxide, and they might give different oxides. Same approach. Okay. So if you don't mind, can I see a raise of hands if you understood this? I think this is the first time we are doing a question like this. So it's not always about writing the entire equation and balancing it. It's about getting the ratio between the most important ones. In this case, the ratio between titanium oxides, it's enough. Right? We don't have this reaction in our syllabus, believe me. We don't have this reaction in our syllabus. Even your seniors will not know this reaction. So here you have to just focus on what is the reactant, what's the product. We don't have to worry about hydrogen and the other compound. I just put it to show you what happens to hydrogen, because if titanium is getting reduced from +4 to +2, hydrogen should get oxidized. If hydrogen is getting oxidized, since oxygen is also there, definitely water is produced during the reaction. But we don't care about water. The water is not a problem for us. Done. Last question, and it is from 2018 one. So 8 once again. Yeah, with this we can wrap up the first session. A metal M was converted to its sulfate M2SO43. A solution of the sulfate was treated with lead nitrate to give lead sulfate. They have given you everything, so I did not give you the reaction. I wanted you to figure out the reaction. If 1.04 grams of M gave 0.09 grams of lead sulfate, the metal M is. Right, let's start. There are a few reactions given. Tell me, how will you convert M to its sulfate? If you want to convert M to its sulfate, that is M2SO4, what should I do? Can you remember from O level? What should be done? If I want to convert M to its sulfate, what should I do, people? I should allow it to react with someone. Who? Hurry up. If you want a metal to produce its sulfate, you have to allow that metal to react with who? Now, for example, if you have aluminium, aluminium will react with someone to form aluminium sulfate. Who is that? No idea. It's not there, no level. H2SO4, viewer. H2SO4 acid. Okay, H not SO2, should be H2SO4 acid. Right, never mind. Let's say you don't know that, that's fine. That's totally fine. Even if you don't know that, that's okay. You can still do this question, because you don't need who is that. They have not mentioned anything about H2SO4 here, people. So let's forget about who that is. I will just directly say M is converted to M2SO4, but you have to be very careful. M2SO4. The problem is you have to balance the reaction. So 2M will be converted to M2SO4, not just M, because there is a M2 here, right? So if I start with X moles of M, How many moles of M2SO4 should be produced then? How many moles? Half of it, no? X by 2 moles of M2SO4. And then that M2SO4 is reacting with lead nitrate. That we can write M2SO43 reacting with lead nitrate to form who? Lead sulfate precipitate. And what should be the other product then? Lead and sulfate are combining to form lead sulfate. So M and nitrate should form MnO3. That is the other solution which will be formed. Right, reaction balanced or not? Reaction not balanced yet. What should I do to balance the reaction? 2M, I can put a 2 here, and 3 sulfur. So I can put a 3. If I put a 3, it will be alright. Yeah, 3 and a 2 here. And a 3, sorry, 3. Right? We have to balance the reaction. This is how you balance the reaction. This stoichiometry you have to carefully figure out. Even if you haven't written this as a product, still you can figure it out, I believe, because 3 sulfate means I have to put a 3 here definitely, and I can put a 3 for lead, and yeah, that is it. Okay, so this is the correctly balanced reaction. And if you have X by 2 moles of sulfate of M, how many moles of lead nitrate will be produced? No, lead sulfate, no? 0.09 grams of lead sulfate. Okay, how many moles of lead sulfate will be produced? X moles of M will give you X by 2 moles of M2SO4. So M2SO4 3, X by 2 moles. How many moles of lead sulfate will be given? 3x by 2, because 1:3. So 1:3, no people? Yes. 1:3, yes. 3x by 2. Good. Right. I think we need to find out X, because the question, look at the question. What is the question about? Metal M is, okay. If 1.04 grams of M, they have given you the mass of metal M. If I know the number of moles of metal M, I can find out its molar mass and decide which metal is that. Okay. All 5 of these metals can have +3 oxidation number, so you can't just look at them and say which one is the metal. We have to find the value of X. If I know the value of X, I know the number of moles of M, I know the mass of M, then I can find the molar mass. Okay, for that, now they have given you the mass of lead sulfate. Where is that? 0.09 grams of lead sulfate. Using that, we can find out the number of moles of lead sulfate. For that, let me start with this. What is the molar mass of lead sulfate, people? Anyone found it? Molar mass of lead sulfate? Okay, the numbers are missing. Lead 207, sulfur 32, and oxygen 4 into 16. That is 64. 96 plus 207. It is 303. Anyone who got 303? 303. I think we used it's given as 303. Oh yes, gosh, it's given as 303. Didn't notice that. Thank you. It's given as 303, already given. So this is a complete waste of time. No, I'm gonna leave it like that. But anyways, it's provided. Don't do that. And then we can go for the equation. Number of moles of lead sulfate. Number of moles of lead sulfate, that is equal to mass over molar mass, because mass of lead sulfate is provided to you. Number of moles of lead sulfate is 3x by 2. Mass of lead sulfate, where 0.09 over a molar mass 303. Right. So the simplifications, this 3 and this 0.09. If I simplify them, it will be 0.03. 0.03 and 303, that is going to be 0.01, and at the bottom 101. Okay, So x is going to be equal to how much? 2 goes up 0.02 over 101. That is x. That is the number of moles of M. Next, the last step, that is we know the mass of M now. Mass of M is how much? 1.04, isn't it? 1.04. So we can find out molar mass. Molar mass of M. Molar mass means mass per mole. Mass or molar mass. Mass of M 1.04. And the number of moles 0.02 over 101. Not liking this. Something is wrong. Wait. Did I make a mistake somewhere? I took this as x, so half of this 3x by 2. Right. Okay. Chromium. Is chromium the answer? But 101 is the answer. From where did that 101 come? Don't know where there's a printing error in the question. Because if you simplify this one, I'm getting an answer like this. 1.04 into 101 over 0.02. That is 104 into 101 over 2. 51 into 101. I'm getting a number like that. Something is wrong here. So that's an answer like 55,200. But the problem is yeah, you're getting that, but I think one of these numbers must be wrong. I think we should check the 2008 paper, people. If you multiply that, it's 5252. Okay, 5252. That's the answer we are getting. Looks like something is wrong with the numbers. It can't be 5,252 gram per mole. It should be 52. I mean 52.52. That means I think chromium is the answer. Somewhere a decimal is wrong in the given information. Where do you think it's going to be? I think this one 1.04 grams. 2 moles. 0.02 moles. 0.02, 0.01, 0.03. 0.03 means it should be 9.09. I think, people. I think there's a printing error. Who has the original 2008 past paper book? 2008. Wait, let's check the 2008 past paper book. I'll take a screenshot of this and make the necessary changes a little later. I think it should be 9.09. There's a printing error there. Chemistry past papers 2008. No, that was 2008. Is it 2008? Question number. Yeah, there's a printing error. Wait, let me share the screen. It should be 9.09. God. Can you see the screen with the correct version of the question? Yes or no? Can someone confirm? Hello? Yeah, okay. Here it should be 9.09. Can you see? 9.09. That's the problem. So that 0.09 is incorrect. We'll have to make a quick change there. That's it. Anyways, the method is fine, but the answer there's a printing error in the question that can happen. So please make that correction in the page through book as well. All right. Right. So this should have been 9.09 instead of 0.09. If that's the case, I think you will exactly get 52 as the answer. Exactly 52. Should be 9.09. 9.09. So let's make the necessary changes. Where should I change that? 9.09 or here? So I'll have to redo these steps, I think. I have to redo these steps. It's okay. It's not going to take a long time. Okay, what here? Number of moles of lead sulfate. Number of moles of lead sulfate is 3x by 2. And mass of that is 9.09 over molar mass is 303. That's even better. It's gonna we are going to get it quite conveniently. 9.09 over 303 is going to be 0.03 over 1. So x is equal to 2 into 0.03 over 3. That is 0.02 moles. Okay, 0.02 moles. That is the value of x. And x is number of moles of M, 0.02 moles. That's it. So now for M, if you go with that molar mass equation, molar mass of M, it's going to be equal to mass of M over number of moles of M. That is molar mass. So mass of M is 1.04 grams. Molar mass of M is, number of moles of M is 0.02 moles. So what is the final answer? 104 over 2. That is exactly 52 grams per mole. So please make that change in the base rule. It should be 9.09 grams. 52 means it's obviously chromium, because I knew 52 means it has something to do with chromium, and one of the numbers were wrong. Anyways, we have figured it out now, and the answer should be chromium. So this is the only way of doing these questions. If they are asking you to find out what is the metal, the only way to do is find the molar mass, and then based on that decide who the metal is. Okay, right. We don't necessarily learn these equations like this step, each equation, everything. You should be able to figure out the equations the way I figured it out with the information provided to you. Okay, good. I think yeah, we can wrap it up with this. How many questions were there, people, altogether? 20 odd, no? Right. So I hope this session was useful, because we did a lot of past papers, and we learned a lot of approaches. So new approaches to chemical